Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring the relationship between quadratic functions and square root functions as inverses of each other. Before we do, let's start with an example. In example 1, it says determine the inverse relation of the function shown below, both graphically and algebraically. So our function in this problem is f of x equals x squared. So this is our quadratic parent function with a vertex at 0, 0, and it opens upward. Now, the domain of this function would be negative infinity to positive infinity. And the range would be 0 to positive infinity. Now, if we want to find the inverse graphically, that means all we need to do is switch the x and y coordinates. So, for example, on our original quadratic parent function, if we were to make a table for the existing points, we would have negative 2, positive 4, negative 1, positive 1, 0, 0, 1, 1, and 2, 4. To get the inverse function, we would simply switch the x and y. So this would become 4, negative 2, 1, negative 1, 0, 0, 1, 1, and 4, 2. Now, let's see what the inverse of the quadratic parent function would look like. So we have 1, 2, 3, 4, negative 2 would be right here. Then 1, negative 1 would be right here. 0, 0, 1, 1, and 4, 2. So our inverse function would look something like this. Okay. Now, I want you to notice that the inverse is not a function. So we would not want to use this symbol to notate the inverse. We will simply be using this notation when we write the equation y inverse. Okay, this is not a function because it fails the vertical line test. Now, to find our inverse algebraically, let's start with our original function and follow the steps for finding an inverse. So remember, replace the f of x with a y, then switch the x and y, so x is equal to y squared. Now we want to get the y by itself. So the opposite, or the inverse of squaring, is square root function. So y would equal plus or minus square root of x. Now, graphically, over here on your graph, this top branch, let me highlight this. This top branch here, this would be positive, the positive square root of x. And our bottom branch, this one here, this would be negative square root of x. So plus or minus the square root of x. Now, the domain of the inverse is going to be 0 to infinity, and the range will be negative infinity to positive infinity. Now, one thing I want to point out is that for inverses, the domain, not only do x and y switch places, the domain and range switch places. So notice, oh, and I need to use my little symbol right there. Notice that the domain of the original became the range of the inverse. And the range of the original became the domain of the inverse. So the domain and range also switched places. All right. In example 2, it says determine the inverse relation of the functions shown below algebraically. So in this problem, they're not wanting us to graph them. They just want you to practice finding the inverse. So remember our steps. We will switch the x and y. So here x would equal y plus 3 squared minus 4. Then we're going to isolate the y. So to do that, we need to add the 4. So x plus 4 would equal y plus 3 quantity squared. Now, to get rid of the square, we're going to have to take the square root of both sides. So, plus or minus square root of x plus 4 is equal to y plus 3. And finally, to isolate the y, all we have to do is subtract 3. So plus or minus square root x plus 4, subtract the 3, and that would be equal to y inverse. So I'm going to write it up here. This is your final inverse. In the inverse relation, y inverse would equal plus or minus square root of x plus 4 minus 3. And we determined the inverse of x plus 3 squared minus 4 algebraically. Now, pause the video and try problem B on your own. All right, welcome back. Let's see how you did. To begin with, I switched the x and the y. So x is equal to y minus 2 quantity squared plus 3. In my next step, I subtracted 3. So I got x minus 3 equals y minus 2 quantity squared. Now I'm going to take the square root of both sides to give me plus or minus square root x minus 3 is equal to y minus 2. And last but not least, I'm going to add 2 to both sides. So plus or minus square root of x minus 3 plus 2 is equal to y. So my final answer, the inverse of y is equal to plus or minus square root x minus 3 plus 2. Example 3. Each of the following has a restriction on the domain. Sketch the original function and its inverse on the same grid, and then find the inverse algebraically. So in problem A, our function is y equals x squared plus 1, and our domain restriction is only for x's that are greater than or equal to 0. So let me draw a grid here. All right, so let me make a table. If I can only use x values that are greater than or equal to 0, I'll start with 0. So if I plug in a 0, I would get 0 squared is 0, and 0 plus 1 is 1. If I were to plug in a 1, 1 squared is 1, 1 plus 1 is 2. If I were to plug in a 2, 2 squared is 4, 4 plus 1 is 5. So I'm going to plot these 3 points. So 0, 1 would be like right here, and then 1, comma 2, and then 2, comma 5. So we're going to have something like this. This is our original function, x squared plus 1, where x is greater than or equal to 0. So basically what we have here is half a parabola. Now, if I want to find the inverse of this function, then I'm just going to switch the x and y's. So instead of 0, 1, I have a point at 1, 0. And then 2, comma 1, oops, I forgot to draw on that point. 2, comma 1 would be like right here. And then if I switch 2, 5, I would have 5, 2. So that would be something like this. So my inverse is going to go off like this. Okay? So here is y, and here is y inverse. Okay? And they want us to find the inverse algebraically now. So we found it graphically, now we want to find it algebraically. So we're going to use the process we did above. we're going to switch the x and y. So x is equal to y squared plus 1. Now subtract the 1. So x minus 1 is equal to y squared. Now take your square root. So we have plus or minus the square root of x minus 1 is equal to y. Now, here's the problem. We have two functions shown here. Let me show you what I mean. Let's see. Let me graph the original function. X squared plus 1. And then I need the curly brackets for the domain restriction. X greater than or equal to 0. Okay, so there's my half parabola, all right? Now, if I were to type in square root of x minus 1 and then negative square root of x minus 1, okay, do you see that I would get two branches, one that opens up and one that opens down? In our picture, we only want the branch that opens up. So I cannot use both of these functions. I have to either use the positive square root of x minus 1 or the negative square root of x minus 1. So obviously I want the one that opens up. So I want my inverse function to, in fact, this will be a function. Oops, I need my eraser here. This is a function because we only have one branch here. So I'm going to use my function notation. F inverse of x will be the positive square root of x minus 1. F inverse of x is equal to the positive square root of x minus 1. We don't want to include the negative square root of x minus 1 because of this domain restriction right here. Okay. All right, let's look at problem B. We have y equals x minus 2 quantity squared plus 3, where x is only greater than or equal to 2. So that means if I were to make a little table here, x, y, x has to be greater than or equal to 2. So I'll start with a 2. 2 minus 2 is 0. 0 squared is 0. 0 plus 3 is 3. So we're starting at 2, 3. 1, 2. So we're starting right here. Let's try 3 now. 3 minus 2 is 1. 1 squared is 1. 1 plus 3 is 4. So 3, 4. So that would be like right here. And we'll try 4 now. 4 minus 2 is 2. 2 squared is 4. 4 plus 3 is 7. So 4, 7. So something like this. So here is our half of a parabola. X minus 2 squared plus 3, where x is greater than or equal to 2. So if I were to sketch the inverse here, I would have a dot at 3, 2, 4, 3, and 7, 4. So it's going to look something like this. So again, we're only going to want the positive branch. We're only going to want the positive branch. All right, now let's find our inverse algebraically. In fact, pause the video and try this part on your own. All right, welcome back. Here we have x equals y minus 2 squared plus 3. Subtract the 3. Take the square root. And I only want the positive square root. And then add 2. Oops. Plus 2. So f inverse of x is equal to the square root of x minus 3 plus 2. Now, let me show you that on the calculator here. Go back here, parenthesis. Here's our original, x minus 2 squared plus 3. That's a full parabola, but I need to put on the domain restriction, which was x is greater than or equal to 2. So we restricted the domain to half the parabola. And our inverse is square root of x minus 3, side arrow, plus 2. So you can see here we have the half parabola and then the positive square root function. So let's box this in. So the square root and the square are both reflections across the line y equals x. And let me put that in dashed for you. So you can see they're a mirror image across that line y equals x. That's because they're inverses. So the fact that square root and quadratics are inverses of each other helps us to solve many problems involving quadratics and square roots. All right, now we're going to go the opposite way. Let's look at the square root. Let's start off with the square root function this time. Determine the inverse function of the function shown below, both graphically and algebraically. So here our function of f of x equals square root of x. So the square root of x is our square root parent function. And you can clearly see at this function that it starts at 0 and then continues to the right to infinity. So our domain is going to be 0 to infinity. Now the range, the y values also start at 0 and they continue upwards, which means they also continue to infinity. So in this problem, the domain and range are the same. Now, if I were to find the inverse of this function graphically, what I would want to do is write down these 3 points from the original, which were what? 0, 0, 0, 1. 0, 0, 1, 1, and 4, 2. And I want to switch the x and y. So if I switch the x and y, 0, 0 stays 0, 0, 1, 1 stays 1, 1, but 4, 2 becomes 2, 4. All right, now let's plot that. So 0, 0, 1, 1, and 2, 4. And notice what I get is 1/2 of a parabola. 1/2 of a parabola. All right, so algebraically, let me write down our original function was f of x equals square root of x. So I'll replace the f of x with y equals. So y equals square root of x. I'll switch the x and y. So x is equal to square root y. And then I want to get the y by itself. So the opposite, or the inverse of square root is the square function. So I want to square both sides. So x squared is equal to y. So f inverse of x is equal to x squared. Now we have a little problem. I'm going to show you what that problem is. Let me type in my original function, square root x. So there's my original function, square root parent function. If I type in x squared, notice that I get a full parabola. But according to our graph, we only want half a parabola. So what I need to do is I need to restrict the domain. And the domain of my parabola starts at 0. So watch what happens when I restrict the domain. So I need a curly brace to restrict the domain. So I'm going to restrict the domain to x's that are greater than or equal to 0 only. And that gives us the half parabola. So the way we denote that on our answer is we say the inverse function is f inverse of x is equal to x squared. Whoops, I wanted a blue pen. But only for x's that are greater than or equal to 0. Okay, only for x's that are greater than or equal to 0. So the domain will be 0 to infinity. The range will also be 0 to infinity. All right, example 5. Determine the inverse function for each function shown below and state the domain restrictions on the inverse. Now, the way I get the domain restrictions on the inverse is by getting the domain and range of the original. So our starting point in problem A would be -3. Let me just graph it for you. I think it'd be easier to visualize it if you see the graph. We have a square root of x plus 3, side arrow, -2. All right. So can I tap on that starting point? Okay, so you can see the starting point is -3, -2. So my domain is -3, and it goes to the right forever. And my range starts at -2, and it goes up forever. So -2 to infinity. And I'm going to highlight the range. This is where you're going to get your domain restrictions. Because remember, in inverse functions, the domain and range switches places. So the range of the original will become the domain of the new. Let me say that again. The range of the original, -2 to infinity, will become the domain of the inverse. All right. Now, let's find our inverse algebraically. So I'm going to replace the f of x with a y. So y is equal to square root of x plus 3 minus 2. Then I'll switch the x and y. So x equals square root of y plus 3 minus 2. Add the 2. X plus 2 equals square root of y plus 3. Now, to get rid of the square root, I'll have to square both sides. So I'll square this side and square this side. So that would give me x plus 2 quantity squared is equal to y plus 3. And then we're going to subtract 3. So x plus 2, subtract the 3, is equal to y. So for our final answer, f inverse of x is equal to x plus 2 quantity squared minus 3. And then I need to restrict the domain. So remember, to restrict the domain, we are using this range because it's going to become the new domain. So for x's that are greater than or equal to -2. Now, let me show you. Here we have the original. Let me just show you real quick what the inverse would look like. X plus 2 quantity squared minus 3. This is what it looks like before I restrict the domain. Okay, so remember, I only want that right side branch. I'm only wanting the right side branch, so I need to restrict the domain. So I need my curly braces. X is greater than or equal to -2. So there's that right side branch. So now that we've restricted the domain, you can see that those two are inverses of each other. All right. All right, look at problem B. We have square root of 2x. So let me graph that for you so you can see what it looks like. All right, so you can see that it's starting out at 0, 0. That's my starting point. So my domain is 0 to infinity, and my range in this problem is also 0, infinity. Now I'm going to highlight the range because that's what we're going to use to get our domain restrictions in just a minute. All right, so let's replace the f of x with y equals. Then switch the x and y, so x equals square root of 2y. Square both sides, and you're going to get x squared is equal to 2y. Now divide both sides by 2. So that would be 1/2 x squared equals y. So our final answer, f inverse of x, is equal to 1/2 x squared for x's that are greater than or equal to, and you go back and you look at your range, that's where you get your new domain restriction, okay? All right, problem C. We have f of x equals square root of x plus 3. So let me show you the graph. Square root of x plus 3. Oops, I'm sorry. The plus 3 is not under the square root. Square root of x, side arrow, plus 3. So that's what it should look like. All right, so our domain is going from 0 to infinity, and our range is going from 3 to infinity. I'm going to highlight the range because that's what I'll use for my new domain restrictions. So y is equal to square root x plus 3. Start by subtracting 3. So y minus 3 equals square root x. Now square both sides. And we get y minus 3 quantity squared is equal to, oh, what did I do? Let me go back. I forgot to switch the x and y. All right. I should have rewritten it like this. Square root y. X equals square root y plus 3. All right, subtract the 3. Now square both sides. So we get x minus 3 quantity squared equals y. So f inverse of x equals x minus 3 quantity squared for x's greater than or equal to 3. Now let me just show you that. If I do x minus 3 quantity squared, see, I get the full parabola, but I only want the one on the right, so I will restrict the domain to x's greater than or equal to 3, and so now we have just the right side parabola. All right. Pause the video and try problem D on your own. All right, welcome back. Let's see how you did. Hopefully you got that the domain was 1 to infinity, and the range was negative 3 to infinity. All right, then I switched the x and y. I added 3. I squared both sides. And then I added 1. And then I wrote it with inverse notation. So f inverse of x is equal to x plus 3 quantity squared plus 1. Then I used the range of the original to get my domain restriction, where x is greater than or equal to negative 3. And that concludes today's lesson on the relationship between quadratic functions and square root functions as inverses.